Before we move on to his other two laws, I want to talk about aphelion and perihelion. What that refers to is the closest point that the planet is to the sun, that's the perihelion, and the farthest point the planet is to the sun, in this case Earth, that is the aphelion. Okay, so it's just those 2 points. The second law is going to be law of equal areas. So a line drawn from the sun to a planet sweeps equal areas in equal time. Planet's orbital velocity changes as its position is in its orbit changes, and it's going to be fastest when it's closer to the sun, and it's going to be moving slowest when it's farther away from the sun. So let's take a look at a figure really quick that I think will help out. Here we have these blue shaded areas and these white areas, kind of like different slices of this orbit. The thing is, all of these areas are exactly the same. They all have the same value. What the law is telling me is that equal areas equal time. So the amount of time it takes for the planet to go from December to January, this amount of time is the same amount of time that it's going to take to go from July to August. Now, obviously, from December to January is traveling a greater distance, which means that if these are the same amount of time, but this is a greater distance, from December to January, the Earth is going to be traveling the fastest. And from January to February, it's going to be traveling about the same amount of time there, or the same distance there, so about the same speed from January to February, but we can see that it's slowing down, right? These are all the same amount of time. It's going to slow down until we get to June and July, then July and August, where it's moving the slowest in those months. And then it's going to gradually speed up as we come back to December. And then we have Kepler's third law, the law of periods. A planet's period of revolution, so the time it takes to complete one orbit around the sun, is related mathematically to its average distance from the sun. And that equation is going to be t squared, t being the period of the planet, equals r to the third. R is the planet's mean distance from the sun in astronomical units, or AU. So let's talk about this in a practice problem. I think it'll become more clear, and I'll show you how to solve it. But Mars's distance to the sun is 1.52 AU. What is its period? So if I have my equation, remember my equation was t squared equals r to the third. T squared is going to be equal to 1.52 to the third. I just plugged in 1.52 AUs in for r. When I solve that out, I get t squared equals 3.511808. Remember, t is squared here, so I need to take the square root in order to figure out what t is. T is 1.87 Earth years. That means it takes Mars what it takes us in 1 year. It takes it 1.87 years to go around the sun. If I want to figure out how many Earth days it is, and this is important, if you want to figure out how many Earth days, you just take the period and you multiply it by 365. So in this case, I take 1.87, the period of Mars, times 365, and I get 684 days. So it takes 684 days for Mars to revolve around the sun. So your homework assignment is going to be as follows. The first one is required, Kepler's law worksheet. The second one is extra credit. If you're trying to get extra points, complete this assignment. If you do not complete it, that's fine. You do not have to. Just a reminder, you only have one required assignment for this week. Have a great week, and I'll see you next time.